Okay, so a little bit about me. I'm a SQL guy, have been for most of my career. SQL Server developer, data engineer, that sort of thing. Different roles, but always with the SQL as the core skill, which I like doing, and mainly in the retail sector as well. But a few years ago, tried to sort of branch out different types of skills, different types of technologies, including Postgres, and then in just looking at data science generally, discovered R. And immediately fell in love with it. The way dplyr and the tidyverse just extended naturally what I was already doing within SQL. And then at the time I was looking at sort of trying to sort of either go freelance or you know, just change up my career a bit. Alongside all this, I love maps. That's kind of my thing, my hobby. I've got big atlases and wall maps everywhere. I meticulously plan out the French family road trip every year, regardless of what the sat-nav says, because I want to know exactly where I am in the map. And I just wondered a few years ago, is there any crossover between that and what I do? So I spoke to loads of people, got a few kickbacks, SQL, maps, that doesn't make sense. But eventually someone said to me, GIS. Never heard of it before, but of course once you get that word, you can Google it, you look up, it's an actual thing. So geographical information systems. So these are systems that allow you to create, manage, analyze, and use and store all types of spatial data. So when we're talking about spatial data, we're talking like, you know, if you take the Google map, the actual raster map itself, the underlying map, and then you might put points on top, points of interest, and then you might link those points with lines, routes, and then you might then enclose all of those points in an actual area, such as a polygon that might represent a postcode. And there's lots of different things you can do technologically with this. There's QGIS, which is a major sort of open source piece of software. PostGIS, which is a natural extension to Postgres databases, but to my delight, of course, you've got R, and there's a load of libraries that you can use with that and do some really impressive things with. Right now, yeah, I've got my own company, Azura Earth, and I'm doing a number of things with different companies, including in the prop tech sector. And I'll show you some of those things that I've been doing with R pretty much at the center of everything that I do. So if you want to get into R and spatial, then SF, Simple Features, is the key package that you need to use. There's lots, as ever, there's always a choice, isn't there, with things. But SF I found to be the key one that you need to use. It gives you all of these spatial type functions, ST functions. So again, if you're used to using dplyr and sort of joining two tables on a key field with Simple Features, you can join things that, you know, spatially. So do these points, do these addresses actually fit inside this particular postcode area? So spatial joins, spatial intersections, that sort of thing. And Simple Features also extends things such as ggplot, which allows you to then it gives you a new geome to allow you to plot things quite easily. And then obviously alongside all, I mean, I'm sure they're all everybody's favorite libraries are there on the other side. But there's a couple of others that I use. 3GS, that's more of a gimmick, but that allows you to sort of put things on a globe. And then MapDeck's really interesting because, again, that's a nice mapping tool, and you can actually flip it into you can tilt it into a third dimension and start extruding stuff out of the surface. So you can get some really good effects with the data that you're working with. So jump into R in a sec, but firstly, coordinate systems. Naturally, I thought, well, like most people, latitude, longitude, that's how you designate a place on planet Earth, you know, where angles extended from the center of the Earth on a sphere, or what is it, the oblate ellipsoid, strictly speaking, which is planet Earth. But where are we? We're roughly about 51 degrees north and pretty much zero on the prime meridian. But as I found, as I started working with data, particularly with UK data, as I started working with data, UK data, I noticed that actually, yeah, not latitude, longitude, we're using the British National Grid. The British National Grid, by Ordnance Survey, what they kind of did was, in simple terms, take a line of longitude 2 degrees west, and if you like, in very simple terms, put a bit of paper over the relatively small curvature of the Earth that is the UK, and then project onto that bit of paper, flatten it out, and you get this British National Grid. It's a nice Cartesian grid in meters. You can pick an origin, so the origin's been selected just west of the Scilly Isles. And what that basically means is everywhere in the UK can then be expressed as a positive number east and a positive number north, eastins and northins, in other words, and in meters. So again, with us around Brighton, we're round about 500,000 meters east and 100,000 meters north. So we can start working with that grid system. I've tried to keep the code to a minimum. I've just put it up there, especially if you're looking at this afterwards, you can see kind of what I've done. But very, very simply, I've got, starting off with a very simple shapefile. Shapefiles are just another way of actually storing geometric data. So you've got, it could be shape, it could be GeoJSON, it could be KML. There's all sorts of different formats, including, of course, directly from a database itself. And all I've got here is a simple shapefile with 2 points. And I've read that in using one of the ST functions, STRead. And you can see there that if I just print it out, removing any mystery from this, it is just simply like a specialized data frame, really. You've just got an ID and name. We've got Eagle Labs here, or just outside the front door, and then Unbarred, the tap room, just around the corner. You can see clearly in well-known text format, clear text format, they're 2 points. Point as in an XY, an east-in and a north-in, in other words. And then we can use ggplot to actually plot that easily. It's not particularly interesting at this stage, but clearly even you don't even have to do any complex mathematics. You can just simply go, okay, Eagle Labs is roughly what, 40 meters north of Unbarred, the tap room around the corner. There's nothing, you know, there's no weird lat long going on here at all. Let's make it a bit more interesting. Yeah, you can see that. Let's bring in some roads and some buildings. So we were dealing with points, but now roads are line strings, as you can see there, and buildings are polygons. And they're just simply represented the vertices of whatever shape you're trying to plot. So line string is the vertices along each straight line segment, and then polygon, all the polygon is the last vertice. The last vertex is the same as the first vertex. It's closed. And of course, you know, there are more complex shapes, but actually these are the key things. So you can, again, plot that using ggplot. Great. There's Brighton, but our area of Preston Circles has now kind of like disappeared. So what we can then do is use other ST functions, and I'm just demonstrating this because it's just they're really straightforward to use. So we've got ST buffer, so we can just simply do a buffer around our 2 points of 100 meters, and then we can pull that as a single polygon together, and then intersect it using ST intersection, and then plot the results. So now we've got something a little bit more interesting. We've got our 2 points. We've got, you know, New England Road. We've got, London Road, and then the various buildings plotted. And by the way, all of this data I've just got from Ordnance Survey. Ordnance Survey, the OS Data Hub, there's a lot of free stuff on there. So you can just download them as shape files and different formats. And yeah, just get into it and try these different things. We'll finally do a route. So a route is just simply a multi-line string, and that is just simply saying, giving us an actual walkable route between here and the Unbarred tap room. And then finally, we can do other things such as ST distance, ST length. Again, really simple things to do. So we know now that, for instance, you know, as the crow flies, it's 43 meters to Unbarred, or a more respectable, 78 meters walk to the nearest tap room. I understand we're not going there. We're going to World's End, but that might not have been as interesting. So, but you know now it's 78 meters to Unbarred, so it's not too far, not too far. The other thing I wanted to say about particularly ggplot is that it's really cool in that you can actually tell it not to use the axes of the coordinate system that we're actually using here, as in the British National Grid. We can still plot it as British National Grid, but if we take that away, we're left with the actual latitude and longitude lines. And you can see here, they're slightly offset. It's very, very sort of like subtle, but what that's basically saying is the actual true north lines going up through where we are and through Brighton are slightly offset to the grid north lines of the Ordnance Survey. So it kind of means that, particularly if you're orienteering, you wouldn't be orienteering here, but you might be orienteering in the South Downs. Your compass and where magnetic north is obviously going to be offset from true north, but again, it's going to be offset from your grid north on your Ordnance Survey map, and it's just something to be aware of. Because if you then zoom all the way out to the UK, you can clearly see why that is. We've got a nice Cartesian grid, the British National Grid on that side, on the left-hand side, and then the right-hand side we've got the same, but actually with the latitude and longitude. So we're slightly north is different for Brighton over here when we're looking at the British National Grid, and the other way when you're in Cornwall. And the point here is that actually there's only one line 2 degrees west or 400,000 meters east, where the two lines agree, the two norths agree. Why is that interesting? Well, I don't know whether you saw on the news, it was late last year, beginning of this year, there was a big thing about the fact the three norths combined for the first time in the UK for the first time. And it wasn't explained very well at all. And I'll try to redress that balance. All it was is basically, and with the power of ggplot, we know that grid north and true north align only one line on Earth. It's a line that goes through pretty much Poole Harbour and then up to Berwick-upon-Tweed. The magnetic north, that's the problem one, but it's very important. It's where your compass actually points to. The magnetic north has been wandering about northern Canada for the past 500 years, and it's the closest it's ever been to the North Pole right now. In fact, it's apparently just the other side of the North Pole from our reference point. So where are we? It's that way, isn't it? So go to the North Pole and then don't stop, go a little bit further. Actual magnetic north is there. What that means is that actually for a short period of time over the next couple of years, that magnetic north is going to pass over, in our frame of reference anyway, the grid north and true north lines, which means at the moment, for instance, just north of Poole, if you're in Dorset, if you're orienteering, your compass will be totally aligned to true north, and in turn will be totally aligned with your Ordnance Survey map. Very exciting if you're into sort of maps and orienteering.
That's why we're here.
That's why we're here, exactly, yeah. Okay, moving on. This now is just looking at projections. Again, ggplot ggplot's great. It can be basic and it can also be great. The nice thing about ggplot, it is one of those things that actually will allow you to do different projections. And what I mean by that is, obviously, we've been working with the British National Grid. You can also work with, if you're looking at Europe, you've got more of a conical projection. So like, think of a squashed hat, a cone on top of the Earth on the Northern Hemisphere over where Europe is, and then project that up onto the cone and then sort of flatten out. And that's what you got on the left-hand side there. It's a kind of the truest representation of Europe that you can get on a flat piece of paper or on a flat screen. The alternative is to do, you could project it in other projection systems. This here on the right-hand side is what's called the Web Mercator. It's the de facto standard because it's what Google use. It's what all the main map providers use. But the issue with it is it's based on the fact that you're taking the whole globe and you're trying to sort of flatten it out. Because when you do that, you get gross distortions. It's not so bad. You can still clearly see that that's Europe and that's Europe. But you can see if you look at Spain on the left-hand side, and the size of it compared to the UK, compared to Iceland and Scandinavia, it's a little bit different when you see it on the Mercator because it's been squished. So Spain looks a little bit smaller than it actually should be. Iceland's getting an upgrade. It's getting a sort of it's looking a lot bigger than actually it should be. And the orientation's wrong as well. So as far as possible, when you're plotting things, if you're doing stuff in Europe, you probably want to use a conical projection. And you can do that with ggplot. And just to stress that point, it gets even worse the further north or further south you go. So Canada, if you're a Canadian map maker, you will be using a conical projection over your country. You certainly wouldn't be using the Web Mercator, which grossly distorts the country. You know that's still Canada, but it's not a true representation of Canada as it hugs the upper part of the Earth. And there is the Web Mercator in all its glory. Like I say, the de facto standard because of what Google uses for all its faults. I'm using MapDeck here, so I've moved on from ggplot. MapDeck's really cool because you can plot something and it immediately gives you a background map. You can use Mapbox or indeed Google. What I've also done then is overlay Greenland and Algeria, and just simply showing from the point of view, again, these gross distortions. Greenland is actually slightly smaller in surface area than Algeria. And yet on this type of view, it always looks like a massive continent in its own right. I think most people know it's perhaps not supposed to be that big, but it's actually quite surprising when you do actually compare it. And of course, conversely, that means that Africa looks a lot smaller than it should be when compared with Europe, especially when you look at it from a globe point of view. Europe's kind of squished right at the top here, and Africa's taken up most of the side. So again, nothing wrong with this. It's just being aware of it. And the final thing I wanted to say on projections was great circles. Great circles are just the natural shortest distance between two places on Earth. So for instance, you know, I've got the red line there represents London or Brighton to San Francisco, and the blue line is Frankfurt to Anchorage, which apparently is an actual route. When you plot it on, I'm using GlobeJS here. Again, just another nice thing that you can do in R, and you can clearly see what the shortest distance would be, what an aeroplane would actually do, how it would actually fly across the Earth. But again, if you're using the web Mercator to do this, you don't want to be just drawing a path. You'll want to be drawing a great circle, and you can do that with MapDeck, and then you can clearly see what's going on. What I think is fascinating about, say, Frankfurt to Anchorage is when you look at a map like this, it is just simply, it's due west. You're just flying west, aren't you? But actually, most of the half the time you're flying north, and half the time you're flying south. West doesn't even come into it, and that's why these sort of things are interesting. They're both right. Again, it's just being aware of what it is you're doing. Okay, there's a whole load of examples there. So moving on, how have I taken all of these basics and various things and done stuff with them commercially with people? One of my main clients is actually Molior. They're a London-based company. They look at property market in London. Specifically, they're looking at brownfield sites where new residential developments could actually be built and take place. And they've already got an app out there. It's and it's been up there for many years. 2D map of London, and you can search it in various different ways. It's a subscription service for their clients, and that's Django, different technology. It's not R, but I was brought on to look at how they can capture better data, how they can analyze that data better, how you could visualize that data better. And one of the first things we did was actually they wanted to try and capture building footprints, and these are buildings that have yet to be built. They just exist on PDF documents or planning applications. They don't exist as geometry. So what they set about, I set them up with QGIS because it's just a nice tool in which to actually draw geometry on, and you can capture that geometry directly into a PostGIS database. And this is just one example where they've captured sort of like the various building outlines, grouped them together in the block, and then I've just simply used MapDeck to then color them according to how high they are. So we've got a podium there, ground floor podium in the dark blue, going up to the 20-story tower block here, a potential building that could be done. And again, using MapDeck, nice and easy to do. You get your underlying map as well, but can you see you've got pitch, zoom, bearing, location that you can play with. Great thing about MapDeck then is you can actually very quickly tilt the map and then extrude the polygons out according to the height attribute. That's one of the attributes they tried to capture. So incredibly quickly, you could get this view, something that actually then they could actually check against, because it brings it immediately to life. This is actually 3D data visualization that works, because you want buildings to look 3D rather than the 2D. The other thing they wanted to do was actually then give a representation of stories as well, storylines. That was a bit trickier to do, but in the end it was just simply using polygons, the baseline polygons here, and giving them a Z attribute. So we've spoken about polygons and line strings, but you can do polygons, multi-polygons, and multi-polygon Zs. And all that means is each vertex, each vertices is just simply can be elevated. So taking the building footprint there and then actually then creating these different polygons meant that we could do something like this. And we started then playing about with different colors. Quite Minecrafty, and that's exactly what the client said. And that's exactly actually what he wanted. He wanted a representation. You know, sure, this might be a glass building with a pyramid on top, but that didn't really matter. It was trying to sort of get a representation of what these new developments could look like in relation to other things. And then that meant, of course, we could start playing about with that and do different things, put the buildings in amongst other buildings, changing the colors and just trying to see what else we could do. But then came the big challenge, the inevitable challenge. I knew it was coming. Obviously, it's great me doing this in R, and I'm sort of putting it up in the plot window, and I'm taking screenshots, and they're including them in reports. Brilliant, great, because this needs to be integrated into the interactive app. You know, they want to be able to select a particular thing themselves. They want to be able to zoom to it. They even wanted to create animated fly-throughs and everything. So I was ready to hand this all over to the Django team because, yeah, of course, I can't do that. But there was no budget. I was actually told it's either me do this or it doesn't happen. Barely scratched the surface of Shiny. I'm not really an app developer in any way. But okay, here's my chance. I may as well just get into it and see. I probably won't enjoy it, but let's see what I can do. I don't know how many Shiny developers there are here, but when you try to get into a new piece of technology, I tend to find first day, absolutely fine. You go through all the tutorials, everything flows, everything works nicely. And then day two, it's a world of pain because you then try to do stuff yourself and nothing works and it's crazy. But the key is getting through that pain. What I found with Shiny was, because there's so many different ways of using Shiny, isn't there? But what I found was, in the end, it was just simply getting my head around reactive values or active variables and observers. Once I got my head around those two actually turned out to be quite simple concepts. The rest just flowed. And using those alongside MapDeck and the various transitions that you can do with it, suddenly I was able to quite quickly build these things. And I guess the point I'm trying to make here is I don't see myself as an app developer, but Shiny has made it interesting. Shiny's made it enjoyable because actually it's quite straightforward. Again, once you get past those basics. So this was one of the apps that we did. This was simply you type in the site ID, it zooms to that site, and then the users can simply move with the mouse, move the buildings around, see the building blocks coloured in different sort of blocks according to. Whoa! It's the can has just exploded. Anyway. Nothing to see there. Yeah. But anyway, yeah. So you're able to, the users themselves were then able to sort of like look around and the building, look at the data that has actually been input against it. But then actually sort of further sort of using things such as MapDeck and the duration and transition elements allowed me to then actually start doing these. They were after these cinematic flybys. How would you do that? Actually, it ended up again being quite simple. Again, once got around the whole observer and the timers and sort of like moving things on. So yeah, this is just one example, just going around some buildings, I think in the Colindale area of London. And then the next stage then was actually to sort of like enrich that with further information. So putting a panel on the side. So again, this is again just Shiny. Let's just play it. There we go. Yeah. This was a little bit tougher, I found, because I suddenly had to get into CSS. I've never got into CSS or HTML before. But again, it turned out to be quite simple. You just get these little snippets in order to change your colors and make things slightly transparent. And again, ended up powering this via a CSV file. So the user, or this was actually initially a staff tool. So the user would actually upload a CSV with a list of sites, and then the actual app would do the rest. And then something else that I've just been dealing with quite recently was to try and see if we could actually give an impression of things actually building over time. So how these sites are actually building. So again, using these transitional elements, being able to do, I mean, this is just a work in progress at the moment, but the idea to actually show different blocks coming out of the ground at different times according to when they're when things are due to be constructed. So yeah, blown away by Shiny. Definitely recommend it if you haven't already got there. It is easier than I thought it would be, as long as you get past that key first step. And the final thing I just wanted to cover, I've been doing a lot of contour work lately. So contours are generally... What's going on tonight, eh? What's going on? I know. Yeah. Yeah, so contours. So contours are usually the lie of the land, aren't they? The height attributes to do with how high the hill is and all that sort of thing. But of course, you can use data to actually create your contours. And we just went through a whole series of different things. You know, if you take, for instance, pricing, pounds per square foot in London for different property types. If you go through a process of particularly triangular irregular networks, which you can do in both QGIS and R, is part of simple features as well. So you're just taking like 3 points, 3 different price points, 3 different locational points, and creating a surface out of that, an interpolated surface. You do that across the whole of London, you get a surface that then you can smooth over and then extract contours from quite easily. And then you end up with a contour map that you can color. So obviously this is clearly showing that Westminster, central London is going to be higher priced than out in the in outer London. But also again, using map deck, flipping it into the 3rd dimension. I'm cautious about doing 3D animations or 3D visualizations just for the sake of it. But again, certain things such as when you're representing things as contours, if you put it into 3D and let the user kind of like pan about, it does kind of elevate the story, as it were, and give you something different. So yeah. What next? I've barely scratched the surface of Ray Shader. Ray Shader is a really interesting one because you can do, this is not my work, this is research for Remora, very active on Twitter and Instagram, does these amazing things using R and Ray Shader. So, you know, population density map of Chile, really, you know, these are longer render times, but really, really stylish stuff. Population density map of England there as well. But even sort of like using, you know, sun rays and things like that. So I want to get more into that because I think, you know, again, that's going to be an interesting one. Map SF I haven't used, but that's an interesting one from the point of view, it appears to be more infographics. So, you know, do a nice infographic, do a more thematic map and put that into your report. Very, very useful. I don't know what projections that one supports, whether it is just WebMercator or whether you can do other things. And then this guy's right. So this isn't R, but Craig Taylor, also known as Mapzilla, I saw a presentation from him several years ago, initially got me into the whole data visualization of maps. He deals with a lot of transport data. And he does these amazing things with, like, you know, he calls them coral cities, transport times out from the center of London, for instance, or, you know, very stylish visual maps of 3D maps of different cities. It's great for inspiration, but a couple of years ago, I wouldn't have thought any of this is possible with R. Knowing what I can do now with what I've done with my clients with the built environment, I think it is. I think, you know, I'd be so interested to see how far we can take R in order to, yeah, and do all these ones. Because I'm only interested in R. I'm only interested in seeing how R. So someone said to me, yeah, finish that off in After Effects. No, don't want that. How can we get to R and then do these things? So in summary, I just wanted to say, yeah, well, obviously attempt to bring your elements of your hobby into your work. I don't know. I mean, I really didn't think maps and SQL went, but obviously it did, and now making a career out of it. So think of what your hobby is, talk to people and see how crazy it sounds. You know, definitely recommend doing that. Know your coordinate systems and map projections, because you will end up plotting your nice map of London in the middle of the Atlantic Ocean or in the Gulf of Guinea. They're generally the 2 key things that you end up doing, and I still do. So it's just being aware of that, and just simply know there's so much to do. You can do with R and Shiny. Shiny is absolutely amazing. I've been absolutely blown away with what you can do. You know, we're not just the secondary kids to that other language. We can actually do this stuff, so which is really cool. I know there's a few GIS people in Brighton. There's at least 3 of us, I think, and there's a lot more people that are interested. So let's perhaps grow that community. I think there's yeah, so much we can hopefully do. Yeah, thank you very much.